Hello and welcome back to another video. In this one we'll be discussing second order differential equations, more specifically second order homogeneous differential equations. Now, in the previous videos we discussed the steps of finding the general solution for the second order differential equation. Uh, in part 1 we obtained the general solution of Rx is multiplied by AR squared plus BR plus C is equal to 0. Now we must find the roots for that second degree equation. Therefore we used the quadratic formula which states minus b the square root of 4ac b squared minus 4ac divided by 2a. We concentrated on that part of the equation here, the b squared minus 4ac, b squared minus 4ac. In part 1 we said if it's bigger than 0, therefore our roots are real and they are different in value. So for example we have r1 is equal to 2 and r2 is equal to negative 2. Therefore our general solution would be c1 exponential r1x plus c2 exponential r2x. Now in part 2 we discussed if that term here, b2 or b squared minus 4ac is equal to 0. Therefore our roots are the same value. So r1 and r2, let's for example say it's equal to 1. Therefore our general solution would be y is equal to c1 exponential rx plus c2 x exponential rx. That's if b squared minus 4ac is bigger than 0, we called it case 1, and if it's equal to 0 we called it case 2. Now case 3, if the term b squared, make space, b squared minus 4ac is less than 0, therefore our roots r1 and r2 are both complex. For example we have r1 is equal to 2 minus 2i and r2 is equal to 2 plus 2i. Our general solution will be as follows: y is equal to exponential alpha x multiplied by a cosine beta x plus b sine beta x. That would be our general solution. As you can see, we have two new terms. We have alpha and beta. Alpha stands for the real part of the quadratic formula. So we have negative b divided by 2a. And beta is equal to the complex part. So we have the square root of b squared minus 4ac divided by 2a. And that's how we find the value of alpha and beta. Now we're gonna move on to a example to make it more clear. Now we have this example which states y double dash minus 6y dash plus 13y is equal to 0. Now, we can't use the brackets method as there is no two numbers that we can multiply together to give us 13 and add together to give us negative 6. So we must use the quadratic formula. So let's write it. R12 is equal to negative b, the square root of b squared minus 4ac divided by 2a. We have the elements here, so a is equal to 1. Here we have 1. B is equal to a negative 6, and C is equal to 13. So we have negative 6, the square root of negative 6 squared minus 4 multiplied by 1 multiplied by 13 divided by 2 times 1. We get 6, the square root of 36 minus 4 times 13 divided by 2, and we get 6, the square root of negative 16 divided by 2, and it would give us 3 and 4i. Sorry, that's wrong. Would give us 2i because the square root of negative 16 is 4i, and if we divide it by 2 is 2i. So we have 3 positive negative 2i. Now we must find alpha and beta. Alpha is the real part of the roots, so we have alpha here. So alpha is equal to 3, and beta is equal to 2i. Now, our general solution would be y is equal to exponential alpha x multiplied by b, that's a multiplied by cosine 2x, beta x plus b sine beta x. So we have the following answer. So we have exponential 3x, a cosine 2x plus b sine 2x, and that would be our final answer. Thank you for watching. Like if you enjoyed, don't forget to subscribe and share if it's helpful.